Weintraub, founder and CEO of Modularity Space, and we're going to be talking about reusable satellites and making space safe. Important topic with how much stuff we have going on out in space now. So I'm going to step back. Scott, welcome. Thanks for taking the time to be with us today. And I'm going to get out of your way and let you talk to us about making space a little bit safer.
Great. So we've got about 15 to 20 minutes. Go ahead and do a little bit of a journey back through past, present, and future space that ties in what Modularity Space is doing. And we have a little bit of time left. We'll touch on some of the challenges we face on really bringing new technology to light. So in 2014, I was studying medicine, and I just knew it really wasn't a passion. So out of nowhere, I transferred to Embry-Riddle to study space operations. And within my first month, I went to a conference and I was listening to one of the world's leading experts on space debris tell me that there's over 1 million pieces of space debris floating around, only half of which we can track. And I just couldn't believe it. When you see a picture of it and there's 1 million pieces of million dots around Earth, it's really hard to comprehend how we've been able to do that in just 60 years. And so I set off on this journey to try to understand why and understand how we can solve this problem. And that's what's led me here till today. So what I started working on was, okay, how could we potentially repair and refuel these satellites? So in 2016, I founded a company called Weintraub. And the idea was, can we build AAA for space? Can we build tow trucks that can dock to a satellite, repair it, refuel it, or tow it to a new location? Maybe that way we can start moving space debris out of the way from other objects. Maybe we can stop it from happening if something goes wrong. And what we realized was there's some fundamental problems in the space industry. Part of it's mentality, but realistically, it's the space industry was built on big aerospace. It was built on government funding. It was built on a political atmosphere of guiding it. And therefore, when commercial space was starting to come online really in the 80s and 90s, we had this foundation that was built on really expensive space systems, 5 to 7 year development cycles, $1 billion+ per satellite platform, and the idea that these satellites had to last 20 years. So we're launching a satellite that took 7 years to build. So it's outdated by roughly 6, and then it's got to last 20 years. And so by the time something comes up and replaces it, we're at a 20 to 30 year window of innovation being stalled. And so we looked deeper and we said, all right, well, what is the problem today? We're now in, this is 2017, we're now looking at CubeSats becoming the major standard. Even just 5 years ago, CubeSats were online, but they're not where they are today. And we looked at the supply chain and we talked to about 1,000 different companies. And what we found was these unique insights that because space is built on these old space practices and methods that revolve around long design reviews, the average satellite taking 2 years to build and costing around $2 million, even though it's the size of a shoebox. The problem is that everybody has to vertically integrate to make it faster. So the only way you're going to build satellites faster and cheaper than 2 years and a couple $1 million for a full mission cycle is if you bring it in-house. And what that does is it stifles innovation. There's really no standard that can be created that way if everybody's building it to their own specific mission. And it kind of drove us a little crazy. And we said, all right, well, building space tugs is never going to work if there's not something designed to be serviced, if we don't have a standard. And to clarify, there is no USB. There is no HDMI cable. There's no auxiliary cord. There's no Wi-Fi. There is no standard connection like we have with computers today. So although there is commercial off-the-shelf technology, every company putting a satellite up likely has a different combination of components. Could be the first time those series of components have ever worked together. And therefore, there's always a lot of recurring engineering that goes into every single mission. And we've looked at standards across the industry for decades. And again, going back to big aerospace and the foundation and the supply chain and vertical integration, there's never really been one that's thrived. There's a number of standards we use for CubeSats, for instance, but there isn't just one that has become a standard for every different component, every different payload or instrument. And so what we decided to do was pivot from trying to build space tugs in 2019 to Modularity Space. And the idea was, can we build reusable satellites that could be rapidly manufactured, so mass produced, that could accept 95% of the different components and payloads and instruments that the industry uses? And could it accept all the different standards that are being used today, therefore kind of creating this interchangeable system for manufacturing, but also for in-space servicing? So a very simple modular Lego-like plug and play connection, like you would think your USB plugs in your computer on the ground, that in space could also be serviced with robotic arms the same way. And this led us down a rabbit hole over the last 3 years of developing these proprietary technologies, both through funding and grants from NASA and the Air Force and seed funding we've raised as a business. And it led us to where we are today. Today, Modularity Space is flying our first satellites next year. We'll move to quarterly launches in 2023. And by 2026, we expect to have 150 reusable satellites on orbit. The constellation, as we call it, is the neighborhood. And the idea is we're looking at every satellite as an apartment complex that has up to 25 rental units that companies can rent. They don't have to build their own satellites anymore. They don't have to deal with the capital. They don't have to deal with the facilities, the resources, the team. They get to focus on their instruments, on their services, and we take care of the satellite. They're mass producible. They're designed for multiple different payloads to be integrated very quickly, as in sub 48 hours. They work with all the industry standards today. And most importantly, they can be serviced in space. And so the question becomes, are we really in a new space industry? Or are we in an old space, but small space, meaning it's new because it's small industry? And I would argue that we are not in a new space industry. I would argue we're on a turning point of getting there. I would argue that things like human space travel and additive manufacturing, as we just heard, are under development, but they're still many years away. And I believe the reason is because there is no reusable platform for them to sit on. They need to take the entire capital upfront and internal development to be able to bring these things online. So if we had a reusable technology in space, not the space station that cost $1 billion a year to run, but a reusable platform that could be reduced in weeks to months, not years, one that can be serviced in space. Can we fractionalize the ownership to where maybe multiple different companies are sharing the sensor suite off to the left? There's companies providing satellite as a service from those sensors to millions of farmers and governments and small businesses who now can have their own space mission in the palm of their hands. In-space manufacturing facilities attached that are building giant networks of antennas and other structures, robotic arms that are assembling new systems on orbit that we're bringing up with the additive manufacturing, and then translation from this technology to support lunar habitats, reusable modules for commercial space flight, where the average citizen who's flying with minimal training can swap out a color-coded module for a life support system if there's a failure, and they don't have to be a trained astronaut to understand how this complex system works. These are the questions we ask ourselves about the future and how do we get there. And it's a big question. It's a big, ambitious goal. There's a lot of unknowns in terms of how do we bring more than just multiple payloads on a satellite together? How do we bring those in space manufacturing? How do we support the commercial space flight? How do we support lunar habitats? But I think it's there. I think we're creating a platform for space tugs to actually have something to service, because right now, pretty much every space tug company you see is raising money and hoping somebody like Modularity Space comes along that they can actually make money servicing, and vice versa. I don't think we're ever going to truly colonize space without having some type of standard to build upon, because when you're on the lunar surface and the power module on the rover dies, you should be able to unplug it and go plug it in to a charging port, or take a battery pack from another rover and plug it in to this one. And I think we're pretty far away from that right now. I think everybody's stuck in the vertical supply chain because there is no standard, there is no reusable, and therefore we've been stifling innovation for 60 years. JFK gave his famous moon speech in 1962. It's been almost 60 years, and everything we dreamed we would have, such as humans colonizing the moon and Mars and space hotels and flying cars, nuclear powered vehicles, we don't have any of that. And although I'm not saying there hasn't been innovation, there certainly has. I think we've lost our curiosity and we've lost the push. And the reason is coming back to the mentality that I started with. I think we're upon a fundamental change of mentality right now where reusable space and space manufacturing, flying cars, drones, robotic delivery, automation, all these things are starting to come online to where in the next 5 years, we might truly see Internet of Things. We might truly see spacefaring civilizations. I don't think we're as far away as many people think we are. I think we're just missing that foundational piece, which is some type of reusable network that can support it all. And that's what our mission is to do. So to conclude, I'd like to use the last part of this to kind of talk a little bit about the struggles we face bringing these things online. And I'm not sure who's buzzing back there, but if anyone's not muted, if you could mute yourself, that would be great. So a little bit about the foundational issues and leadership issues we face being the leadership conference. I think it's a massive uphill battle to try to change an entire industry's point of view, especially one that's 60 years old, built on old space that we call new space, but in my eyes, I think is small space. How do you do that? I think we're going to have to prove it. And that's exactly what we're aiming to do. So with flight starting next year, we already have both satellites almost completely full. We have 3 satellites planned in the next 24 months. 2 of those 3 are going to have space tug companies come and dock to our satellites, refuel. 1 will have a robotic arm and actually demonstrate changing out modules. This is a monumental step for changing the mentality of the industry and showing that it can be done. And we're not a decade away from doing it. We're a matter of 24 months away from doing it. That this technology exists today. And when you combine it in a unique format like we have, solving a number of really challenging problems related to reusable mass production, integrating multiple different, dozens of sensors and instruments together very quickly that we've been able to solve, we're looking at a monumental change in the industry. So the mentality is probably one of the biggest challenges to overcome, but also I think it's a major leadership challenge. So to talk a little bit about leadership on some of the things that I'm implementing and practices that I've picked up through research, I think the industry lacks humility. I think it's a hard trait naturally for humans to accept. But when I do customer outreach or when I'm talking to people, I'll ask a very generic question, and it's very hard for people to admit they're wrong. It's very hard for people in this industry to admit that someone else might be right. And I think that goes into changing the mentality of accepting that even the newest intern on your team might have a brilliant idea that can benefit the company, or somebody else in a different industry is developing something that is suggested to you that could be used, and you should be open to listening and understanding how that could be implemented, because we've been stuck in 60 years of old space for a reason. And it's because I think we've lacked the humility to really push the boundaries of opening up our ears to other people and their thoughts. Another one I would say is a challenge is ownership. From what I've seen, this point now going on 7 years, I've probably touched close to 2,500 space companies alone, not including everyone else I've worked with. And I would say that it's very hard to find ownership, people who take ownership in the work where, hey, this document was late, for instance. We missed the deadline. Why did it happen? And then the blame just gets passed around back and forth. Further into communications, I would say the space industry is one of the absolute worst industries in form of communication, because it takes on average 6 months to get through meetings between 3 to 4 different companies to finally get to a point where you can sign a contract. there needs to be a massive push in ownership. People need to step up and start streamlining communications. They need to accelerate the time of onboarding customers and figuring out ways to implement faster development cycles. We were trying to procure a satellite for one of the missions next year. For propulsion alone, there's over 20 companies we looked at for propulsion. Not a single company could get us a propulsion module in less than 12 months. 12 months. Not a single company could build the satellite for us in less than 2 years, full mission cycle. It took less time to build the Empire State Building in 1930 than it takes to do your first mission in space today. There needs to be accountability, there needs to be ownership, there needs to be humility, and there needs to be a push for innovation in terms of how can we do things faster? How can we think differently and think truly new space and not small space where we've just shrunken everything, but we're still building it off the same 60-year-old manufacturing practices. So in conclusion, that's what my mission is as the leader of Modularity Space. I am trying to embrace humility. I'm trying to push ownership. I'm trying to push innovation. And I'm trying to change the mentality of the industry that there is a better, easier way to do this, that reusable space is upon us, that reusable space is the foundation to opening up the dreams that our forefathers had, mankind has had, looking up at the stars and exploring it, and trying to get founders and leaders motivated again to push these boundaries and create enormous value and change, because otherwise we're going to go another decade and we're going to see 1 or 2 innovative companies come online, and we're going to be stuck in the same racetrack. And by racetrack, I mean that when you look at a subsector of the space industry, such as Earth observation, that is imaging of the Earth, you see a dozen of the exact same companies trying to compete as if they're on a racetrack going round and round, and one of their cars is a little bit faster, or one has a little bit better engine, meaning a better sensor. And I think it's the wrong way of thinking. I think if you're looking at doing the exact same thing as everybody else, and you're going to beat them because your sensor is just a little bit better, or you think you can get a satellite up a little faster, I think it's the wrong approach. So saving space comes down to an entire mentality change. Space debris is out of control. The mentality we have now of this old space practices has led to over 1 million pieces of space debris. With over 50,000 satellites proposed over the next decade, I believe we're going to pollute space so bad that we might see a Kessler syndrome, which would equate to massive collisions in space. We're already seeing a daily occurrence of having to move space assets because of space debris. And I don't think there's any way possible that we're going to be able to put up 50,000 satellites with what we have. I think there needs to be a fundamental shift and change towards reusable space systems to save space. Space tug companies coming online with a business model to now make money with, so they can put more effort into cleaning up what we've already polluted and making an entire shift to save space. Otherwise, in my opinion, in the next decade, we might lose it. So guys, that's all I had. I hope it was informative. These are my views on things from the last 6 years of researching and understanding. Some might agree, some might disagree, but I hope it was helpful.
Awesome. Thanks, Scott. Very needful conversation to be had, considering, as you say, all of the kind of pollution, as we call it, going out into space. And so looking forward to seeing kind of what the future holds, and appreciate you guys being a big part of that space and doing the work. So
yeah, have a great day, guys.
Thanks, Scott.